Hello, everyone, and welcome to another K6 Office Hours where we talk about all things K6. I am Nicole van der Hoeven. I am a developer advocate, and I'm here today with my coworker and trusted colleague, Paul Baylog.
Hello,
Okay, maybe I
everyone.
instantly regretted
Sure.
it once I
Yeah.
said trusted. Should I have said that on air?
That's
We
right.
should
It's never a
redo
good
it.
thing. I am so not trustworthy.
How are you doing today, Paul?
Doing good, doing good. And hopefully, as I was warning before we went on air, just in case, I'm a little nervous about my connectivity today. So let's hope the demo gods are in our favor and smile upon us. And I forgot to burn my incense today. So
Yeah,
yeah, we'll see.
offerings to the demo
Yes.
gods.
Yes.
Ah, rain dance.
Yeah.
Ah.
But
Okay,
yeah.
let's get started. But first, I guess let's talk about just for people who need a little bit more context. What even is a Kubernetes operator?
Kubernetes operator is the coolest thing ever. So no. So Kubernetes, I mean, obviously it's the system that is like the system operator that never sleeps. It's you don't have to worry about waking them up at 3 in the morning or anything like that. But yeah, it's gonna keep your workloads running and make sure that all your applications are up and running, hopefully happily. It can't do complete magic, but it definitely helps. But with the operator, that is just a way to introduce custom functionality into Kubernetes. So they have it's called a custom resource definition, and it's just a way to enable custom APIs so you can create your own kind of Kubernetes. Really bad description. Sorry.
I kind of think of it as like a manager for custom resources.
Yep.
But I guess why would we want custom resources in Kubernetes in the first place?
Yeah, I mean, so sometimes Kubernetes, they don't have the foresight to know everything that you're going to need. So in our case, we have this where we want to be able to run multiple instances of K6, different, the same script on multiple instances. Well, we use the operator as a manager to be able to divvy up that script into elements and say like, hey, you run this piece of the script, you run another portion of the script, and it controls all that, so you don't have
Yeah,
to.
and I guess you could write your own, but that would be quite unwieldy, and it's usually best if it comes from the people that make the tool that it's for, just because they would be a little bit more familiar with it, and that way people aren't making it over and over again, right?
Definitely. I mean, yeah, creation of custom operators and CRDs are not for the faint of heart, unfortunately. It's not you're not going to be doing that every day. So
So tell us about K6 operator.
all right. Well, K6 operator, it's very cool. It's actually fairly new to me. I just kind of started working with it here in the last couple months, but yeah, no, it's pretty cool. I think our previous CIMA was originally creating that, and it's been a couple years. And now we only have one developer actually on staff that kind of supports it, unfortunately, and she is it's just a part-time gig. I mean, it's not officially her responsibility to
Yeah.
take this on. So unfortunately, if you are watching the issues and things like that, it might be a little slow to evolve, but yeah, it's been around for a couple of years though.
Yeah, so we've done two previous office hours on this topic. The first was with Simon Aronson, or Sime. As
Yep.
Paul was mentioning, he was the creator, or one of the creators, I think. Our other colleague, Daniel Gonzalez Lopez, also had something to do with its creation. And then I did another one with Hans Knecht, who is not from K6. He's from Mission Lane, but he is an avid contributor of the project. But it's been a while. There are some things that have changed, and I think what I'm most interested in seeing is that you today have like a whole flow from us. I know when I demoed this last, it was kind of like, well, here's how to run it. But as for the metrics part, that hadn't been fully fleshed out. Another major difference is that since the last one, we've been acquired by Grafana. So obviously, we've not had any trouble prioritizing some of the work in integrating with Grafana projects in general.
Yeah, yeah, and I'm hoping with this demonstration, which is one actually that I provided to the CNCF as well, which is Cloud Native Computing Foundation. They're I guess the foundation that's overarching for Kubernetes and Prometheus and several other projects that most everyone is depending on. But let's see. But yeah, so and the key thing is that really is the focus for this demonstration really is the installation of it, running the scripts, understanding how those scripts are executed, and then also showing that you can change the back end. So, most folks that are running K6, they're used to running it a single binary, and then they may get the output directly in the console to show the result summary. Well, with this demo, I'll actually be using it to output metrics as the test is running to a Prometheus service. And actually, it's going to be in the Grafana cloud where I'll be pushing that and actually using the free forever cloud. So I'm not, this isn't for a commercial for paid service or anything like that. This is showing you what you can do for free.
All right. So with Kubernetes, with the K6 operator, I think the main advantages are that it lets you do distributed load testing, which is a mode that we've wanted and we've had requests for in K6 all the time. And I think this is a really big advantage because with distributed load testing within Kubernetes, that means that there really is there's no pressure to have to set everything up on your own on the cloud or to use K6 Cloud. You still can do those things, but you can also just do it yourself. And the Kubernetes component of it is pretty awesome too, because even if you're not doing distributed load testing, there are some significant advantages to moving your load testing stack into a Kubernetes cluster as well, especially if you're already doing that for your other application components.
Yeah, no, definitely. Kubernetes makes things nice.
Yeah, and I think also, before we jump into your demo, I think last time we talked about this, I don't think Prometheus Remote Write was available yet.
Not by default. It's still in there as just as an extension. So you'll see that we'll compile in the Prometheus Remote Write extension for K6.
No, I mean, in the last, I think, more than a year ago, before the Grafana acquisition, I don't think we had Remote Write yet. I'm not entirely sure, though.
Okay. Well, yeah. I mean, I know with as far as like the extension or as far as like support from Prometheus or
yeah.
But
okay.
But anyway, I know there was
today,
some early playing around with Prometheus. I had to enable. There was a feature flag essentially that you would have to enable to say that yes, enable remote write. But now it's become really pretty much the default on Prometheus. So even with the Grafana Free Cloud, the remote write is available.
Okay, awesome. So if you've made the necessary, arrangements with the demo gods, maybe what do you feel about jumping in?
Let's do it. Yeah, so here, let me go ahead and share my screen, and hopefully I've made everything legible and readable and all that good stuff. Let's see.
Hey,
But
quick question
yeah.
before you
Mhm.
start. I'm interrupting you already.
No,
KL
I saw.
Diello says, can we please elaborate more on the advantage of moving K6 or load testing stack into Kubernetes?
Yeah, so I mean, so there's no changes to your scripts by chance, just to at least have it run in Kubernetes. But the advantage is going to be just the larger number of virtual users you could run. Because I don't know if anybody pays attention to all the K6 Testing Tuesday social media thing that we do. This last question was related to kind of the maximum number of virtual users you could have in a single instance of K6. Well, we've had up to like what was it, the range was 30,000 to 40,000 virtual users is kind of a limit on a single instance. Well, in Kubernetes, you're now going to have multiple instances running the same script, so now that just increases the number of virtual users you could do. So now that's really 30 to 40,000 virtual users per pod. So now obviously you're going to have a decent sized Kubernetes stack. So you're going to want each of those workers to be able to have enough resources that you can run 40,000 virtual users in each pod. But that's going to be the big thing. So that's going to be where Kubernetes is going to really come in to shine when you want larger load tests.
I think it's also about shifting left and treating load
Mhm.
testing scripts and other testing scripts in general, actually, as code because they are code, just
Yeah,
like
yeah.
application code is code. And for the same reasons, for the same benefits that Kubernetes brings to application code, it brings to testing code as well, meaning the declarative way. In with K6, it's a little bit different, and it's an interesting mix of declarative and imperative forms of programming because the scripts are still imperative, but there are going to be like the custom resource for K6 is declarative. And there are advantages to that, to having both approaches. Just as a refresher, declarative means that instead of saying step 1, step 2, step 3, do these things in sequence, declarative is like, here is the end goal. This is what we
Yep.
want to get to. Now get there
Yep.
somehow.
I
And that's
want
the
a blue
magic of
car.
Kubernetes.
Yep.
Yeah.
Exactly.
And then there's also the idea that pods are atomic, meaning they are broken up, they're modular. They're not one big thing. They are smaller things that can be individually tweaked. So you could have resource limits for load testing pods that don't apply to, your application pods or your database pods or whatever else.
Mhm.
And in Kubernetes, pods are also ephemeral, which reinforces best practices for load testing, so that you're not relying on manual configuration of your virtual machines for load generators, which means they're more reproducible.
Yeah. Yeah. I mean, that's yeah, it always makes me think, talking about that with the ephemeral pods and things like that, that always brings up, it's a horrible analogy, but they say, treat with pods, it's like you're treating it like
Cattle,
cattle
not
rather than
pets.
pets, right? Yeah, because with a
Yeah.
virtual machine, you're going to be taking care of that system, or just like any other server hardware, you're going to be applying your patches and upgrades and things like that, and manual configuration in there. But with pods, it's just like you create one in its place with the newer version, so you're continuously updating each time. So instead of doing an upgrade, you're going to say, okay, delete that old one, replace it with the newer version. So yeah.
Great. Okay, sorry to interrupt. I just wanted to answer that quick question. Please go for it.
Wasn't so quick, was it? No. But
Whoops.
yeah, no, but feel free to interrupt as necessary. But anyway, but yeah, so I do have this demo. This is all in a repository, public repository that anyone can get to. I can throw the URL in there. So if anybody wants to pull it down, or just follow along with the instructions. I'll go pretty much through this. And again, like I said, I'm only using the free software. So, I went into Grafana and I created my own personal account. I mean, even here, I have I have a virtual private server that I run, and then don't laugh at the low counts on my server. Nobody wants to see what I got, but anyway, these are my Nginx logs, so I'm pushing them up to my Grafana Free Forever account, so I can have these cool dashboards and things like that for that. So I've also created a couple dashboards, obviously blank right now, but for these Kubernetes tests. And actually, I saw that Wenceslao is on line. It looks like he's attending, and I snuck his dashboards that he's creating for the Prometheus remote write project, for the XK6 project. And then anyway, so I tried to recreate them. So we'll see how I did. You'll see that I'm not a dashboard guru, that's for sure. So anyway, I'm going to go ahead and pop over here, and I'm going to go through the steps, and I'm going to go and create a Kubernetes cluster that's just running simply locally on my machine. It's I use a prod called K3D, which is Kubernetes and Docker really, and then it will set up K3S. I'll have multiple nodes and multiple workers, so it's going to act and appear just like a real server, or cluster rather. So let me go ahead and get started in here. Let me find my cheat sheets here, and we'll proceed. So in this case, if you pull down the code, you'll see I have this dependencies directory. So if you want to add into this and customize and add different extensions into your version to play along, you can do that. Just simply, clone the projects, and then you'll see that I have a note in here about, where to hook in, so that you can build with all this extra stuff. And you can use Docker for that. So you should not have to have a full Git set, or I'm sorry, not Git, but a full Go setup, I don't think. Since I have it set up that way, I may be lying. So anyway, I'm going to go through here, and then I'm going to go and just build my little setup here. So I'm now going to actually create my K6 image. So this is going to pull in all the extensions. It's going to create my custom binary that I'm going to actually execute within these Kubernetes pods when we go and run a test.
Can you make this a little bit bigger?
Even bigger? Oh man, things like massive on my screen, and here I thought I was already making it large enough. Yeah. Okay. How's that?
That's good. Yeah.
Okay.
Thank you.
All right. So okay, it's still building right now, but again, this is the normal. This is using XK6, so it's building my custom K6 binary right now, and it's doing it within Docker, and it'll create a new image, which I will be publishing to my Docker Hub. Now I've already got this, so I'm not actually going to go and push it up again, but you'll see that I have this demo operator, and this is where I publish the image to, because with Kubernetes, it's going to want to pull that from some sort of a container registry. Now with Kubernetes, everything's going to be image based, so container based. So it's going to, when it goes to start up, if it doesn't already have it locally in the cluster, it will download from Docker Hub, or there's a GitHub container registry as well, and then it'll pull down that, so it can create the pods.
So Paul, this, would you say that K6 operator is an extension or something else?
No, the operator is not actually an extension. I mean, it's a separate product, really. It's not like any of the other extensions, like with Prometheus or MQTT or anything like that. You're not going to interact with the operator within your JavaScript tests. So that would be a kind of a discerning thing. I mean, you can pull in the Kubernetes extension and then work with Kubernetes directly that way. So then you could actually, I guess, interact with the operator. But yeah, I don't know. That's I don't really see a good use for that offhand. There might be, but yeah. So now what I'm going to do here, though, I'm not going to worry about pushing up this image since it's already there. But I will go ahead and I'm going to run this script here. Now, again, this is kind of a nasty looking command line here because this is Docker. So it's going to actually mount a volume. So that way then it can access directly the actual test scripts that I have in the project. So that's these scripts here. Okay. Now it's not the prettiest command line, and therefore I have this little cheater script here, which it is actually a simple script. Let me find it here. Run local, okay, and then all it is doing is it's doing some fun things just to make sure that you pass in the script name, and then it'll just take care of all that other nastiness for the command line. So I do like to use this script just for that reason. So I'm just gonna run just a simple one, and just to show that. Oops, wait a second. Let me try running from here for that. Okay, so this is using the Docker image to actually run K6 just like normal. Okay, so this is strictly locally, no big deal. This is all that. And it's not even doing the output to Prometheus in this case, just local standard run. This is just to verify essentially that my image is good. So we're going to go through here now. And then now I'm going to go ahead and create my local Kubernetes cluster. Okay. So this is where the magic of K3D comes in. And this is, again, this project is awesome. So we'll see that here there's 3 different agents. So those are essentially the worker nodes. So I'm having a 3-node cluster of Kubernetes in this case. And this will finish up here in just a second. So I'm creating this brand new cluster. And then that means now I could use kubectl to actually, get pods. There's nothing in the namespace, or I can use even better this K9s. I recommend everyone use this. This is it's a nice command line based user interface for accessing Kubernetes clusters. So I can come in here and then look at all the namespaces. Okay, so I have a perfectly good local Kubernetes cluster. Okay, so now I'm going to go and start installing the K6 operator. All right, I'm going to pop in here again, because I pulled into the directories. I pulled in the source code for the operator itself. I have it here, so I'm going to actually just use this script, which run this command real quick to deploy into our environment. So here, all this, it shows that these are all created now, and you don't have to worry about too much about the details of all these different things. These are some of the plumbing that just allows the operator to work. Hooks in there to listen for the K6 type, which is now created. Let's see. We go here, we can go to CRDs, and then we'll see that now we have created this K6s custom resource. Can drill into this, and then we can see all this nasty stuff that is required for Kubernetes. So again, you don't really need to worry about this too awful much, hopefully never, to run anything. Okay, so I'm going to go ahead and go back to namespace listings. Okay, and I'm going to do a little bit more setup. So now some of the things that I'm going to do is for the demo purposes, I'm going to actually run this so I can have a separate namespace for executing all this. I've got that. And now this is very important here too. So what I'm doing here is that all these different test scripts, now in order to make them accessible to the K6 operator and to your scripts to actually trigger the tests, I need to load those into Kubernetes. So the mechanism that we use for that is a config map in Kubernetes. So I'm going to go ahead and run this real quick. And I'm just loading those test scripts from my directory here. So I'm just populating this into the Kubernetes cluster. And then we'll pop in here now, and we'll take a look. We'll go ahead and change into the K6 demo namespace. All right, and then now we'll take a look at config maps, and then we'll see that here's this test scripts that we just created. So now if I drill into this, you'll see that all it is it's basically a key value pair. So it's just saying that if somebody is looking for doorbuster sale JS, they're going to get all this. And this is, oops, yeah, that doesn't render nicely. But so this is, again, this is just your standard typical K6 test. Okay, and then there's multiple. So this is just your repository of your test. Now, this is one of those things where you want to hook in, good GitOps practices so that, the test is code. So if you were making changes to your test scripts, you would have something in your backend and like in Git, so that would listen for changes. So when you merge a change into a test into your main branch, that it automatically updates this config map in your Kubernetes cluster. So then that way, then as you make any changes, it's automatically getting pushed in there, and then it'll be available. So you don't have to. You don't want to have to do this every time. I mean, obviously, I'm doing this locally, so that's just something that you have to set up. So now I'm going to go pop into here. Now there's some other resources. Yeah, and these are the ones that I won't share with everyone, because these are going to be my personal credentials and things like that. So this is where I'm going to actually set up. They're called secrets in Kubernetes, and then also some other config maps that are going to have things like the Prometheus endpoint to write to and things like that. So I'm just going to go ahead and run my script here, okay, which creates these things. And we can safely come in here and see this one. I don't mind sharing that this is the endpoint, and it's assigned to this K6 Prometheus remote URL environment variable. So when the pod starts up and it's looking for Prometheus endpoint, it's going to use this environment variable. Okay. Similar with the secrets, I can pop in here and I can show you that here, at least in the display, it doesn't show the unencrypted value, but you can see that I've created these two different environment variables that'll be loaded in by the runner script. So I have my Prometheus password and user. Mm-hmm.
Can I also ask you if you can increase the size of that terminal window?
Oh my. Okay. There you go. Is that better?
Yes, thank you.
I can go larger.
Even better.
Okay. All right. Don't tell me your eyes are as old as mine. So
I mean, I'm the one with glasses here.
Well, I don't need mine for up close, but I need them otherwise. So all that's set up now. So we have all our secret credentials for my Grafana free cloud. We have the credentials and endpoints for even the K6 cloud. Now I have two different versions of K6 cloud. I have one with the free account that I'll demonstrate, and then also I have one for my work account where I actually have all the subscriptions and that would be like a like what an enterprise customer would actually have. So we've got all that loaded, so now we can actually do the fun of running tests. So let's go ahead and take a look at what the script looks like. That here's a basic one. Okay, and let me go ahead and get rid of that. Okay, so normally, you use your K6 run and directly on the command line. Well, obviously for Kubernetes, it's going to be different. What we're going to do is we create a resource. Okay, and that resource is of type K6. Okay, this is what our CRD makes available to Kubernetes. So our CRD defines and says that, oh, okay, if somebody says that they want to create a kind of K6, there's some of this other metadata is all there and everything, but the CRD defines all the options that we have available to us. Now, again, this is a very basic instance. And, one of the main things that we have to do to trigger something is to say the parallelism. So that means just, how many K6 instances do I want to have this script run by? So in this case, 2. And then this just kind of points, okay, where is that script in Kubernetes? What is going to be run? And this, I'm just telling it, use the test scripts config map, which, if you recall, was here. So that was just our repository of all the scripts. And then it's going to say use the file, or simple.js, which again, if you recall, I said these are kind of like a key value pair store. So look up the CS key, and then value will be this script. So that's what this particular script would run. So here's one now that this is the one that's going to actually have the command line options to output to Prometheus. Because if you remember with the basic, it's going to be just console output. You'll see the result summary, and then that's it. It's not outputting metrics to any third system. So in this case, I want to output to my Grafana Free Forever account, which is Prometheus based. So in this case, again, it's kind as K6. I'm going to say, run four K6 nodes or pods in correct Kubernetes speak. Okay, and then in this case, I'm going to go ahead and I'm going to run the simple JS. And, again, it's, I know one of the complaints we often hear is that we have a lot of our test cases are a little too simplistic, and I apologize, but yeah, this is, it's hard to get good. It's better to build the foundation of understanding first. So we're going to stick with that. And now what I'm doing is here, I'm going to provide these additional arguments. Now, this again would be provided on the command line if you were using just the K6 binary directly. And I'm passing along a tag, and you'll see that why I'm doing this shortly, but this is just going to give an extra attribute or a label that we can use in Prometheus to be able to kind of keep all these, each test iteration or each test run separate. So it'll just make our dashboard a little bit nicer. And then, of course, here, if we come down here, this runner, this is going to be each pod. Now, in this particular case, I was working a little bit with some of the folks from the Dapper project, which is another CNCF project, but they're using K6, and they wanted to inject some of these annotations. And anyway, there was some issues that they were having, and we got that resolved. But so I have that there. In this case, I'm telling it what image to run. So again, this is my actual K6 image. So this is the one where I said, okay, build the custom K6 with that K6, include all these different extensions. And then I pushed it up to Docker Hub. Well, that's the address for that image. So that's where it's going to pull that. And then I'm also telling the runner that I'm going to bring in these environment variables, look out for them. So here, this is the same thing as if I would have done, instead of that, I could have done up here in the arguments, I could have said the -- output or -o, and then specified Prometheus output there. But here I elected just to do it with the environment variable. Now, this makes it a little bit more flexible by using the environment variable, because now I can run that exact same script easily to different targets. And you'll see here in shortly, but I'm also now pulling in some environment variables from the config map, and then also from the secret. So those, the username, password, and then the Prometheus endpoint. So all that's
I think that
defined.
is actually one of the new features since the last
The
time
env
that
from,
yeah. It just makes it a little bit easier in the case of secrets. But I also thought this might be a good time to tackle another question from KL. How do you ensure that K6 pods do not necessarily compete with the resources assigned to the application pods happening on the same Kubernetes worker node?
Yeah, that's where the magic of Kubernetes comes in, and resource limits. So with Kubernetes, each pod has resource limits where you say, okay, I want to have this portion of the available memory. I want to have this proportion of CPU usage. And then what Kubernetes will do is, based upon your request, your ask of it, it'll determine which node or which worker to put that workload onto. So Kubernetes is looking at all the requests for how much memory and CPU each application wants, and then it'll run it to distribute it as evenly as possible. So as long as it has the resources, you should be fine.
Gail also goes on to say, I'm more concerned about moving K6 into Kubernetes cluster, leading to inconsistency of test results, either due to throttling in K6 pods or starving the application pods due to K6 pod on the worker node. So since we're talking about worker nodes here, totally agree about the resource limits. That is a really that this is one of the ways that we as testers can also test a Kubernetes application or make tests on Kubernetes better. There's static testing by just looking at the manifest, at the YAML configuration, and trying to see whether these things are set, because it's always good practice to have resource limits. But another thing that I think we can do is to set affinity and anti-affinity rules. So you can have rules in there that say that tests have an anti-affinity with the test pods have anti-affinity with the application pods, meaning
never run
if
on
you
the same
have
worker.
two different pods, they won't, two different nodes, they won't run on the same one. So as much as possible, they'll try to be separated. I personally like that. It's not always possible, right? But it is a good idea. Danielle also says,
Yeah.
it's good practice to have a pool of nodes only for the K6 tests. You can do that with selectors, which is exactly what I was talking about as well. As much as possible, even though they're both code and can be can be stored and versioned in the same repository, it's still good practice to have a separation. Just think of it as an experiment. You want to reduce the variables except for the ones that you're testing.
Yep. Yeah, no, definitely keeping them isolated, and then, isolated between namespaces as well. And then, all that, because there's some internal networkings that, Kubernetes takes care of, and access and all that. So yeah, no, it's definitely good to keep them separate. But yeah, with the resource limits and everything like that, it should be managed pretty well. And that if anything exceeds those limits for enough time, then Kubernetes will be responsible for killing it and replacing it with another. Is there any?
Awesome.
Okay.
No, I just thought I would bring that up so that, because you were mentioning we were on the YAML file already.
Yeah. But yeah, and then as far as that env from, I believe that is one of the newer updates. I think that was earlier this year, but a few months ago. But yeah, so that definitely makes it nice where you can then extract all those the secrets and the configurations and that, and keep that out of the YAML as much as possible. So all right. So we have that now. So this is actually, consider this file here, this resource, is your trigger for running your test. Okay. So now you would use kubectl to apply that resource, to introduce it into Kubernetes. Now, again, I have created my own in the test, which will actually do that as well. And what I like to do is, because I have this test ID, I'm using my script to actually create a nice, unique identifier for the test run. And it's just based off of the name. And so I'm doing some little fun in here, and not required, but to actually take the name of your script and put that as part of this tag, and then put a timestamp on there. So we can just keep things separate. And then there's also this, it deletes any existing instance of that trigger. So in other words, you can't just change it. You have to delete the previous execution if there was one, and then, recreate it. All right. So yeah, so this kind of nastiness here, I'm updating the YAML on the fly. So in this case, if we take a look real quick, yeah, I like my bash scripts. Sorry, I'm a little old school. So, but what I'm doing is I'm just coming into this YAML file, and I'm just going and saying, okay, find this test ID, and then I replace this with the name of the script, the portion, and then a timestamp, and in that way, then in my dashboards, we'll see that directly. So let's go ahead and then, oops, let me bring up my terminal again here. Let's see. Normally I use, I typically like to use, what's it called? Goland. I'm kind of used to using that always as a development environment. So let me go ahead and get out of here. Let me go into pods, and now we'll see it's actually running. So this initializer is what's actually started now. Okay, and then this is pulling in that image. You can see all this good stuff. Right now, it's going and creating each of those pods. So now I had the parallelism to 4. So if we look here, we can drill into these and check out the logs. And then I did notice this. Oh yeah, this is actually okay. I was a little concerned. I think a recent update, it's looking specifically for a 200 return from Grafana, but it's getting instead of 204, which is still a success as well. So the actual metrics are being sent up there, but it's kind of the extension doesn't realize it's actually fine. So here, this is.
Quick question. Can you confirm that using the config map is the way to bring the K6 script copy into the cluster, correct?
That is correct. Yes. Yeah, I think there's actual other methods as well. You can do things like you can mount a volume to the cluster, so you wouldn't have to do it via config map. I have seen something in there about that, but yeah, the config map is just kind of, to me, it feels a little bit more natural or simple. And then what the config map does in general. Again, a config map is basically, it's a key value pair. Think of it as like, on Windows, it's your INI file, or, it's just it's your config properties. It's a properties file. And then the key being the script name in our case, and then the value actually just being the actual contents of the script. Hopefully that answers that question okay. But yeah, so now I'm going to go over here. So we've actually executed this, and then again, we can look at the logs from each one of these. Oops, let's go back so we can see, and we'll see what the operator did when it was starting all this up. It looks at your script, and then it says, okay, you want 4 for the parallelism. So it knows it's going to create 4 pods. And then it's going to look at the script further at like the options. So in this case, I think this particular script, let's take a look at this. Okay, I was doing 10 VUs. So it's going to take those 10 VUs and it's going to distribute that across the 4 pods that we're going to be creating. So we'll have 1 pod that's going to, or 2 pods that'll have 3, and then 2 pods that'll have 2 VUs each. So if we take a look at this, we'll see that here, this is a single instance. So this particular pod had 3 virtual users, had 335 of the requests were performed from this. Now, if I look at another one, and again, it's just doing that because it was over a few minutes ago. Well, that's kind of weird. This one did, 1 at the end there, I guess, and then 318 requests. And this one will do that. This one had 2 pods. And this, okay, I guess that was, okay. Well, there was 10 altogether, should have been. So let's take a look now at our dashboard. So this is what I was doing with that test ID tag. So it just makes it so that I know that this iteration was from the simple script and then this timestamp. We ran overall 1065. So between all 4 pods, that's what we received. So we'll pop into here. And then, like I said, I tried to recreate some of the dashboards, and I'm not exactly a great graphinista as far as creating the dashboards. I still have to learn that a bit more.
Shame.
I know, right? Throwing shade on myself here, and rightly so. But yeah, so this will show here that we had the active VUs. We were up there at the end there. It was 7. So interesting, but yeah. So that was that particular execution. Now I can go and let's go ahead and run it again, but let's do a different script. So again, this was my trigger script. It's all set up for doing the output to Grafana. So now really all I need to do is I'm going to change this. I'm going to do my little door buster. It's not really a door buster. It's just a simple little with a ramping script. Just again, very simple, just hitting the test site, just to get a good understanding. Okay, and then that's really all that I have to do differently. Now, again, because this is just a change, that previous execution has to be removed. So with my little script here that I used, I actually delete the previous, and then it'll recreate a new one in its place with the new settings. So again, if we just pop into these, we can see that the execution, any logs, we can come back here and I guess I could just set this to auto refresh. And once the metrics are sent to Grafana, we should start seeing this populate. Now this overall test, I think, only runs for like 10 seconds, or 30 seconds, I believe. So I wasn't able to reach some of that. But anyway, here, so doorbuster sale, this, and then we can watch as this is as the metrics are coming in.
Great.
So that, okay. All right. Yeah, so that test is still actually running. But yeah, so just to change the script, that's all that was required. Let's see, was there any
Yes, we have a question here. Michał Zarod says, I might be ahead of your demo, Paul, but could you include some thresholds to your test script? I tried to set up a test with K6 Operator with output to K6 Cloud free tier version, but I'm getting an error from K6 Operator Controller Manager about the free version not supporting thresholds processing, which is a bit weird because running locally with Docker Compose with output to cloud works just fine.
Yeah, let me okay, here, let's so one of the examples that I had pulled from the Prometheus output is this multi-scenario here. And now this one I know does fail some of the thresholds. So let's go ahead and we'll go ahead and execute this one. Let's see. So if we do multi-scenario and run that, and we'll just do the same thing again. So that'll delete previous iteration, and now it's recreating. And then we'll let that run here for a second. Now I know this one definitely does fail some of the thresholds. Because you'll see that after it fails them, you'll see that the status here of the pod will show that it's in an error state. And that's because it returns a non-zero value. So even though the script itself was actually successful because there were thresholds exceeded or not met, it returns the error status. So that's where, obviously, yeah, in your CI/CD pipeline, you could fail a build or whatever. Now this one's going to be a longer running script, though, so I will probably kill it shortly. Well, see, we can kind of
In
set
my
up for the next
last
one. Mhm.
In my last office hours with Hans Connect, I know that he was saying that thresholds are not evaluated at runtime. And I believe that has something to do with the fact that thresholds normally in K6 are all just run by the single
In
K6
single,
instance.
yes. Yes.
Yeah. And so in this distributed mode, the problem is that the result aggregation is not there. Now, the way that he suggested getting around it is by doing like what Paul did, piping it out to Prometheus and then to Grafana, and then
Mhm.
setting thresholds and doing the aggregation after, like downstream.
Yeah. But each one of these pods though is interpreting the thresholds independently
Yeah,
as
but
well. So
nothing
I
for
mean,
the
so
whole test.
not for the overall. Yeah, you're not going to get for all four, you're going to get four individual ones. So you could have one pod that actually succeeds because it didn't encounter any the threshold issue, but then the other three pods could fail because they did. So yeah, it's kind of weird that way, but yeah, it's not aggregated before applying the thresholds. So let's see. So here we got this guy. So yeah, so if we pop in here, we'll see that this one looks a little bit more exciting. So again, this one's still running. Yeah. Um. So hopefully, I don't know if that was a good enough explanation on that. Again, like I
Yeah,
said, those thresholds will be applied by each of the pods independently. So
yeah, so maybe this is a good time to talk about some of the limitations because it's not perfect. We've
mhm,
already talked about one of them, and that's the fact that there's no global results aggregation or
right,
threshold evaluation. But there are ways to mitigate that and still understand what's happening as a whole, especially if you're integrating with Prometheus and Grafana. I guess another thing is that this definitely requires more technical setup than
yes,
if you were, say, paying for K6 Cloud or something and just running it that way without using the operator. By the way, Paul, one of the main changes in K6 Operator, and I don't know if you've tried this out yet, is that you can actually run it on the cloud, on K6 Cloud.
I have. And that's where I have this other script here. So the K6 Cloud, you mean where we output to K6 Cloud? And that's
Yes.
Yeah, and that's what I've got here in this particular version. So now this one again, it's where we can run the simple script or any of the scripts, honestly. And then here I'm just, let's see, same image, but I'm changing some of the environment variables. So this one will be for cloud output. And then this has my credentials for the cloud secrets. So this runs the exact same way. I have this wrapper, but instead this time I'm going to tell it to go to K6 Cloud. And let's see, I'm doing the simple. So there we go. So now if I pop into here, this is my free K6 Cloud, no subscriptions that I pay for. But let's see. And we should see this start. K6 Cloud is created. We should see a pod come up here shortly. I think my machine is kind of crying now. Here we go. See if you notice here now these pods have aired out, and that's only because there were thresholds that were encountered.
Mm.
So it didn't pass all the thresholds, so non-zero is returned. But otherwise, the test itself was, fine. Let's see. With this massive display, I don't have my little refresh button up here. So, but yeah, so yeah, I'm all messed up. Let's see. So here we go. Let's see if that created. Okay, so here we go. So right now this test is running, and then it's outputting to the K6 Cloud. Now, one caveat though about this though is that you may see that there's only one single node running, one pod, and that's because with K6 Cloud, with the free version, you can only have one instance emitting metrics at one time. But yeah, so if I pop into this, we'll see the normal K6 output as this is running.
I actually I reached out to our customer support, Victor, and asked him how you can run with more than one. And he said this is actually available for the enterprise plans.
Yep.
Of course, yeah. I want to reiterate that while we are showing this in K6 Cloud, it's because it's available to us, but you don't need K6 Cloud to run this. In fact, you don't even need to do this in any cloud. You could do this on-prem if you would like.
Yep. And here, let's see. So that's that one there. And let me go back here too. So this is one of the fun things that I like to show too, is that in my free account on Grafana, I set up the K6 Cloud app, and this is actually hooked up to my free the Lookma no subscriptions. And here now I can see from the K6 Cloud, I can see the actual execution. So it's this in
look,
Grafana.
Nicer dashboards.
Look at that. Yes, and better dashboards than what I can create. So but yeah, so that's that piece there. And then I can actually show with the paid version as well. So I have this with my subscriptions. Okay, so this one I'll run the multi-scenario because that one does look cool. And I'm going to have it running 4 pods. This is out to that. I have my subscription secrets there. Okay, so all I have to do is then, let's see, K6 subscriber. And now if I switch over to this one, so this is my pay one, I can show here. I'm guessing I'll zoom in there again. And any moment we should start seeing some activity here there we go. So the cloud subscriber version now is actually outputting here. So again, because this is an actual paid one, it allows multiple runners to be emitting metrics to it. And we should get the nice output here starting soon.
Great.
Yeah, so that's pretty much the
Yeah, well, while we're waiting for it, maybe we could wrap up on what the advantages are for using K6 Operator.
I mean, again, if you need to have tests that are over 40,000 virtual users, or even not, I mean, it's to spread out that your requests. K6 Operator works great. I mean, again, this is something that you would normally otherwise have to have the K6 Cloud, the public or the subscription version to run distributed. But this gives you that ability.
Yeah, distributed load testing is definitely useful. I think also though that one advantage that we maybe don't stress enough is that it is just it cuts down on management overhead to have K6 running within a Kubernetes cluster, especially if you already have a lot of things on Kubernetes, then it kind of makes sense. It's kind of bringing the whole testing experience a little bit closer to your SREs or platform engineers. at K6, we do try to be as engineer friendly as possible, and that's not just test engineers. Having K6 as a custom resource means that pretty much anyone can just start tests when they want to, and it's going to be reproducible. Like, they don't need to, because there is a configuration file, they don't need to do that manually each time.
Yeah. Yeah. And I mean, and then the same can be said too, though. So yeah, if you're on Kubernetes already, absolutely bring in K6 operator and use it there because, yeah, you have the knowledge to support that. And same can be said with, use of Grafana. I mean, that's if you're using Grafana for all your observability, it makes sense to have your load test metrics being output to Prometheus as well, or any could be influx, could be time scale, whatever. As long as you can create your dashboards in Grafana, that way then you have your observability and that data all together and take advantage of what you already know.
We are unfortunately out of time. I do want to say, Paul, that maybe Michelle, you could reach out to Paul because he did want to know if you could run the test with a threshold with the output to the cloud, but we probably don't have time to demonstrate that.
Yeah, and that's the one that's running here now, and for some reason it's not showing any displays just yet.
So where should people go if they want to use K6 operator?
Just go straight to GitHub, pull down the project. Unfortunately, it's not the most straightforward for installation. You have to use the make file, but we'll work on that. And then,
awesome.
Yeah. And then we're adding to the community. I think there's another section that we'll be adding specifically for the operator as well. So we'll try to get some discussions going there as well.
Great. And so there is the K6 operator repository. And for the example, so that you can reproduce what Paul has shown today, I also put the link to his specific repo in the comments. And here it is again. All right. Next week, we don't have K6 office hours because we at Grafana Labs have a shutdown day. So thank you, Paul, for coming on to show us this. And anything else you'd like to say before we close off?
No, not really. And I think this error message, this might be what was discussed there. So yeah, I'll have to dig into that myself. So yeah, thanks.
Fine. Almost made it with demo guides. I think your rituals need tweaking.
Exactly. Hey, but the network survived, so.
Yeah. All right. Well, have a good 2 weeks, everybody, and we'll see you in a bit. Have a good weekend.
Bye. Everyone.